Welcome to Maintainable, the podcast where we explore the art, and sometimes the mess, of software that's meant to last. On this show, I speak with seasoned practitioners who have spent years inside real systems navigating technical debt, untangling legacy code, and helping teams make thoughtful decisions about long-lived software. Today, I'm joined by Rein Henrichs. Rein is a principal software engineer at Procore and has been part of the software industry for over multiple decades. Rein joins us from Portland, Oregon, not too far from me. Rein Henrichs, welcome to Maintainable.
Thank you, Robby. It's nice to be here.
So given your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
I actually just want to talk about one, which is that well-maintained software makes sense to the people who maintain it.
Tell me more.
So we often think about software in terms of the code that we write, the stuff that's running on different machines and different clouds. And what I'd actually like to talk about is the stuff that goes on in our heads when we're trying to write and maintain and operate software.
How do you know if everybody has a shared understanding of what the code base does?
That's a very good question. That is exactly what I want to talk to you about. So let me introduce a mental model that's been very helpful to me. This mental model is called the line of representation. This comes from, in the early 2000s, Richard Cook, who was originally an anesthesiologist and had a very prolific second career as a resilience engineering researcher and practitioner. He wrote a paper called Above the Line, Below the Line. And what he pointed out is that when we're working with a system, whether that's a software system, whatever kind of system we're working with, we don't actually directly interact with the system itself. We interact with our understanding of the system through what's called representation. And so if you are familiar with Plato's cave, that allegory from the Republic, where basically the idea of Plato's cave is there are some prisoners that are chained in a cave facing a wall. And then behind them, there are some real things that are passing in front of a fire. And what they see is the shadows that fire projects of those things on the wall. And what they do is they mistake the shadows for reality. And that's actually just what we all do all the time. In the context of software, those shadows are things like logs, metrics, dashboards, code editors, SSH sessions. And then the real objects are the actual system state and execution, what's quote unquote actually happening on these computers. And then the prisoners, which might be an apt comparison, are the people who have to operate, develop, and maintain that software running on those computers via those representations. And so the line of representation says, what we typically think of as the quote-unquote real system is happening below the line, but all of our work to work with that system, to understand it, to maintain it, to develop it, happens above the line in our shared understanding of the system. And so with that model, the thing you're asking about is what's called common ground, which is our ability to work together in mutually predictable ways. And we each have our own understanding of the system. And just like we don't have access to the actual system, we also don't have access to each other's understandings. And so we only get glimpses of these understandings by the things they say to us, the things they do, by our observations of their behavior, right?
Just to kind of interject there for a moment. So I'm just thinking about that example. Let's say the prisoners, and there's like multiple prisoners, and they have their own individual experience of what they're seeing projected against the wall from the shadows. How do we truly ever really know that we have a shared like we both see this and say the same thing, but do we fully, I guess that's like, we get back to the whole idea around the common ground as well there. But I appreciate this in like a philosophical sense. And I'm thinking like, well,
sure.
For someone listening.
What do you actually do about it?
Yeah, exactly.
When you have a shared understanding, what that means is that you have an aligned view of what is currently happening, what has happened recently, and what matters most right now. And so this is sometimes called shared situational awareness. And you also have to understand what the group of people who are doing this work together is trying to accomplish, what the shared goal is. You have to understand what success looks like to the group right now. And you have to understand what are your current priorities and how have those priorities shifted. So all the stuff that leadership gurus talk about alignment and vision, that's not just happening at the upper echelons of the organization. That's happening day to day in the work that software engineers do with each other.
So for the person down, say on the ground floor, and they're collaborating. So like, let's say there's an incident happening, and like walk me through how you think about onboarding somebody so let's say there's someone listening and someone's new joining their team. You have some strategies for how to communicate both vision, but also here's how we're going to wrap our head around what our priorities are. Like if there's a specific situation where there's an incident happening and try to make sense of it. Like, how do you think teams can best distill that and then like bring other people into that fold?
Yeah, and incidents are a really, really great thing to look at if you want to understand this, because if you do this poorly, you'll know it quite quickly. And because they compress a lot of the challenges of software maintenance, of general software development into a short time period with high pressure and high consequence, right? So what can you do during an incident to build and maintain common ground, right? What you need is the stuff I just said. You also need what's called mutual predictability of action. In other words, I know what you're going to do, and you can predict what I'm going to do. And if you've ever heard people talk about cowboys during incident response, these are people that just go off and operate on the system in ways that they think are correct without telling anyone about it. This can be a real problem for incident response because even if those actions are correct, they change the system state in a way that other people aren't aware of. So a lot of this is about setting expectations, and the incident commander can do this. And so whenever I'm commanding, when I start the call or when people come on, I will set some ground rules. And my job as an incident commander is not to make every decision. It's not to take every action. I might not take any actions against the system. My job is to manage the coordination of the people towards this joint goal. And so the ground rules I set are, if you are going to act on the system in a way that might change it, not just harm it, but change it, you have to let us know and get a confirmation before you do that. And that's very simple. You say, hey, I'd like to do X. And then I'm going to ask you, okay, what are the consequences of X? And then if we understand those consequences and we think it's a good idea, you can go do it.
You know, I think it might be helpful at this point to maybe take a quick step back. And so for listeners who might not be familiar with like kind of your background and where you, let's say right now, take it, for example, you work at Procore. So what does the company do and the software do, and what kind of product and engineering environments are you working in right now? And approximately like what team sizes are?
Yeah. So it's been a while since I've been trained on the elevator pitch, but Procore is a software as a service company for the construction industry. So we have a full life cycle software service. It's a website that people go to. It manages all their construction documents and processes. And it actually, one of the things that it does when it's working well is it keeps people on the construction site. It maintains that shared understanding for people on the construction site of what they're trying to accomplish, what's currently going on, what's important, what's next. It does this so that when people think about this sort of workflow management software, they think it's about documents, they think it's about workflows, right? And sure, there are, 50 different types of document, or, so whatever. And there are a bunch of different workflows. But actually what's important is if each person on the construction site knows what they are doing, and what they are doing is aligned with what the project needs to happen next.
So it's kind of like, it's overly simplistic, but project management, but like,
Yeah, this is project management for the construction industry. It's for owners, it's for general contractors, it's for subcontractors, it's for architects. It's all the way from pre-construction to post-construction. It's a full suite of integrated software construction industry project maintenance tools.
So if let's say, if there was an incident with the software.
Yeah, we don't have those. We never have those.
Yeah, it's potentially derailing or slowing down or impacting people on job sites.
Yeah, so what gets people mad is when the software they're using prevents them from getting their work done, right? Then they wish they just didn't have that software.
And then you're like, we didn't always need software to do this and all the things that... But yeah, you did. Or some version of something.
I mean, we haven't had an incident that's so bad that they have to get out the filing cabinets again, right? So most software does not fail. It operates in some degraded mode, right? So in any non-trivial software system is typically failing partially in more than one way at a time. There's all sorts of stuff going on. We're delivering, a few hundred commits a day, probably more. We're probably merging 20 branches a day. I'm not sure what the actual numbers are. The likelihood that there isn't a single issue in any one of those commits is quite low. The reason that the software continues to work is, first of all, that it's been heavily guarded against failure. There are all sorts of things that we've done based on the failures that have happened in the past that allow it to continue to operate in this degraded mode. And this is what's called graceful extensibility in resilience engineering. But to answer your question about incidents, we do see incidents. They typically have what we try to do is we try to understand what their bound is, what their scope is, how many customers the incident is impacting, in which ways the customers are impacted. This actually can be quite hard to do. But any given incident is typically a partial outage of some component or something like that.
Hey listeners, it's Robby here. You know, it wasn't all that long ago I'd find myself debugging a weird issue in one of our clients' Rails app. I log into one platform to track down the error, only to realize it was tied to some performance issue. And guess what? That meant hopping over into a completely different tool and trying to match things up based off of timestamps, if I was lucky. And let me tell you, my productivity didn't exactly thank me for that. Enter AppSignal, our podcast sponsor, and the tool that eliminates all that back and forth. They bring error tracking, performance monitoring, host metrics, custom metrics, uptime monitoring, and logging into one seamless platform. It's a single source of truth that helps keep your app running like a well-rehearsed symphony. Whether you're working with Ruby, Elixir, Node, Python, or tracking front-end errors in JavaScript, AppSignal has your back. They're always adding support for more languages and frameworks too. And here's the best part. AppSignal won't break the bank. Plans start at just $23 US a month. Plus, they're ISO 27001 certified and fully GDPR and HIPAA compliant, so your data is safe. Oh, and because you're a loyal Maintainable listener, you can use the promo code Maintainable at checkout for 10% off your first year. So head over to appsignal.com. Tell them that your good friend Robby from Maintainable sent you and start making your app sing. And approximately how many engineers are over at Procore these days?
I think it's somewhere between 500 and 1,000. I'm not exactly sure.
Seems really scientific there. I love that. Talk to so many engineers and they don't really know how many engineers there are these days. It's a big number to kind of wrap your head around. So when you think about, like, with your role there, if I recall, your role was your principal engineer there. So what does that look like in practice at a location like a place like Procore?
It seems like principal engineer means something different at each company. That's what I've learned from talking to other principal engineers in the industry. My job is to provide a sort of backstop of technical leadership for the domain that I work with. So I work with a few different teams, and I provide a sort of a backstop in the sense that my goal is to create self-reliant teams where I don't have to work with them on a day-to-day basis. But at different times, I might need to spend more time with a different team. And that can be around basically doing architecture stuff, so the large-scale design of systems. That can be around helping develop a sort of engineering culture that would benefit the team. So in terms of how we do code review, I try to model good code review behaviors. I try to be available to answer, or at least, contribute to the discussion of difficult technical problems. I do not at this point do a lot of day-to-day software development. That seems to sort of come and go depending on the needs of different teams.
How consistent between different teams do you find that you're able to get when it comes to like their workflows, or do you end up depending on like the type of team or the makeup of the team, like, well, this one's like a little different, so the workflow is going to be different. You mentioned code review maybe as one particular thing, and maybe that's more consistent, but are there some workflows that are maybe just a little bit different?
Yeah, it varies on each team within constraints that are imposed by the organization. So we have a more or less standardized software development lifecycle in terms of what the Jira columns are, for example, and what the workflow looks like. But then the practices on different teams can vary quite a bit in terms of, for example, what the definition of a shovel-ready story is, or who does which code review, or how the work is allocated, or whether they pair or not. And, one of the things that the organization needs is what's called synoptic legibility. They have to, at a glance, understand or be able to read what's going on, right? So they want to, someone who's, a VP and is managing 30 teams or whatever, They don't have time to dig into Jira and go look at the boards, right? So they need things that can roll up to them in ways they can understand this. And that's called synoptic legibility. And so when organizations standardize on these things, it's not just to benefit the teams, right? It's also to benefit the people who have to manage it. And that can sometimes be intention.
Do team members tend to move between teams very often? We have to learn to adapt to different, like how different teams?
Yeah. I've seen that at Procore in two different ways, more than I've seen it at some other companies. One is that we do have people that move from team to team. Two is that we have more people than I've seen elsewhere transition between IC and management tracks. It doesn't happen every day, but it's probably happened 10 times more at this company than I've seen at other companies.
Has there been much of maybe this is too much in the weeds there, but has there been many instances or a few incidences where people did make that transition and then not that long later be like, actually, I'd like to go back?
Absolutely. Yeah. And what's interesting at Procore is that this has happened all the way up to pretty high levels of IC.
And technically with your role, is that considered kind of IC still?
Yeah, I'm in the IC track. So Procore now, there's principal, then there's senior principal, then there's architect, and now there's also principal architect. So that's the top. We have one distinguished engineer, but for practical purposes, the top of our ladder is principal architect.
Now for like kind of digging back into the lower level details. So like talk about software just as a kind of like general thing. In older systems, important behavior maybe isn't always very obvious, as we were discussing earlier. So how does that uncertainty tend to show up for teams that are maintaining the software?
Yeah, it often shows up as what are called weak signals. And weak signals are signals that are difficult to detect, also difficult to interpret, and they're also not sufficient on their own to form a judgment. In other words, there are some signals where you see this and you go, oh, that's an incident. But there are others where you see this and you go, oh, is that an incident? And that's a weaker signal. And so when you have this sort of lack of common ground, a lot of the organizational issues, they show up as weak signals. And it can be difficult at an organization to attend to weak signals, to pay attention to them, to value them, to think about them. In part, that's because of the pace of a modern organization, of a modern company. We just don't have enough time often to reflect on things that really require reflection.
Can you give me an example of like maybe a tangible, say in a web application, we're talking like a weak signal, like, oh, we got there's some errors that are coming through, like it's a JavaScript thing. Maybe that's an issue. I don't know.
Exactly. So if you've ever looked at a dashboard and go, that's a weak signal, right? If you've ever looked at code smells are weak signals. Anything that you're looking at can give you weak signals. It's not restricted specifically to software. It's not restricted specifically to project management. They're all over the place.
How do you think these weak signals affect planning and, say, estimating how much time something?
When we talk about like planning and estimation sort of being vibe based, a lot of it is that we have some awareness of weak signals, but we haven't been able to actually process them, right? So there are lots of weak signals that, for example, a software project or any project is off track. One of the weak signals that's interesting for software maintenance is that our understanding, our clarity about how a system works doesn't improve over time. If you see that, then that's a signal that something is going on regarding software maintenance that you could try to improve, because maintainable software is understandable software. And so if you see these weak signals that we're either struggling to understand the software, struggling to share that understanding of the software, that's a weak signal that is suggesting that you should invest more in maintenance.
Do your teams have a approximate formula for how much time they earmark for dealing with, air quoting for our listeners, maintenance type work versus whatever new feature, new development, however people decide to categorize things? And do you feel like there's like a really clear distinction between the two?
Yeah, I don't. And this is one of the things that can vary a lot across teams. One of the things that I try to institute with my teams is the use of SLOs as a way to operationalize this problem. In other words, SLOs are a particular collection of signals about what we understand the customer's experience of our software is. And we can use those signals to make prioritization decisions. What I don't have, and that's relatively easy to operationalize because either this thing is red or it's not, or either this line is going down or it's not. And when you have SLOs, what you also have is an agreement with your product manager or whoever does that side of the tripod that when it looks this way, we're going to do something about it, right? And that means shifting our attention towards maintenance, towards recovery, towards whatever's necessary to get back into the green, quote unquote. What I don't have is the same thing for maintenance. And so what we've basically done with SLOs is we've taken these weak signals that the customer is experiencing issues, and we've operationalized them. We've turned them into something quantifiable that we can make decisions about, right? And so that's exactly taking a weak signal and operationalizing it. But I don't know right now, unfortunately for your listeners, how to do this at scale for maintenance. I'm certainly attentive to weak signals, and I try to help my teams be attentive to weak signals about the need to spend more time on maintenance. I don't know how to turn that into a number.
Do you think everything deserves a number?
So it's interesting. Edwards Deming, who's a famous management guru, is often quoted as saying, if you can't measure it, you can't manage it. That's technically true, but the full sentence subtly changes the meaning. The full sentence is, it is wrong to suppose that if you can't measure it, you can't manage it. A costly myth. And so one of the things that managers have to be good at is operating in this liminal space where they can't measure it, but they still need to manage it.
It's an interesting paradigm. I think a lot of, say, management likes numbers. I run a business. I like numbers. And it's always interesting about, actually, I was having a conversation about this yesterday with somebody, and this was unrelated to code specifically, but it was just about the types of metrics that we're able to track in a software consultancy like me, and how I've been so focused on trying to have more leading indicators and less lagging indicators. And that distinction there being and I feel like a lot of software metrics tend to be lagging metrics that we can report on, here, what's the current state of the situation? Or, maybe there's some leading indicators, even then it's I don't know, maybe you have a different perspective on that, but I'm going off a little ramble here though. But yeah, I think there's these subjective things too about how people feel about the software, how maintainable it feels day to day. But sometimes teams need numbers to help them show that they're making progress so that you can improve the subjective perspective of how things are. Because we've talked to teams where they'll be like, hey, things are just not great right now. And it's not been great for a while, but you're like, well, are you measuring if you're making progress so that the team can see that? Because if you live in a day-to-day, you don't really know if the water is getting warmer. I'm thinking about the frog in the boiling water situation or whatever. But yeah, I think, what's your kind of take on that?
Well, I think it is challenging to do this well, to manage these weak signals well, or to manage the things you can't measure well. And so it takes a certain expertise skill set to do it effectively. Not all managers have that, although I think it can be trained. But what this basically means is it's very difficult to operationalize, in the sense it's difficult to replicate. It's difficult to scale. So it basically relies on what you might call rockstar managers. If you have a team with a really good manager who's able to do this, then that team can function well in that highly uncertain environment. But a different team, and it's not just the manager, it's the capability of the team as a whole, right? But a different team with a different set of skills might struggle. And so whenever you have something like this, it's important to do, but hard to operationalize. That's where a lot of businesses really struggle.
We'll be right back with our conversation with Rein. Hey, it's me, Robby. I just want to say thank you for listening to the podcast. If you're enjoying these conversations, please leave a review on Apple Podcasts or Spotify to help spread the word. You might also drop a link to this episode in your team's Slack or Discord or wherever your teamers are hanging out. You could even just send it to your CEO and say, listen to this. Seriously, listen to this, CEO. Maybe you are the CEO and you could just email it to yourself. I don't know. Anyhow, thanks for listening to Maintainable. If you think you know someone that I should have on the show, maybe your CTO, I don't know, maybe you, send me an email to Robby with a Y at maintainable.fm. All right, let's get back to our conversation with Rein Henrichs. I think of in those situations, like you mentioned if you say a rock star manager in the team, whatever, the secret sauce of that team can be very, very difficult to replicate. And because it sometimes like that dynamic of that team can drastically change as soon as one of those ingredients moves on, and then you're like, what happened? I thought this team. So how do you think about replicating some of those aspects of the secret sauce? Because not all the teams are going to say make the same sauce, I guess, but you want to have that as reproducible or as consistent as possible. Sounds hard.
So I think that's a very astute observation. In complexity science, this is a thing that is called being highly sensitive to initial conditions. In other words, a small change in where the system starts can lead to a large change in where the system ends. And a team that is operating well can be disrupted by a seemingly small change. Someone leaves, someone joins, the team is reorganized, the team is kept whole, but now the reporting structure is different, right? All sorts of seemingly small changes can disrupt a team's ability to operate. And then that's one problem, is repeatability in time under changing conditions, right? That's one aspect of operationalizing this problem. And the other aspect is sharing it from team to team, getting all teams to a similar level of ability, right? And if I could solve this, I would be a millionaire. What I've seen work is the long-standing opinion is that learning organizations, and there's a lot of organizational theory on learning organizations are able to steer. Learning organizations are able to choose from the processes, the procedures, the rules that are available to them based on the outcomes they want to have. And there's a lot of literature about what a learning organization is, how to build a learning organization. What is lacking is proof that you can do this well. So I think Russell Acuff, and this was decades ago, but I doubt that it's different today. He said that 75% of organizational transformation initiatives, managers report them as being failures. I don't think that's that much different today.
This actually reminded me of completely, maybe slightly coincidental. And I was thinking about how teams and the dynamics of how teams change, and it reminded me of one of our prior guests, which was Heidi Heflin, who wrote Dynamic Reteaming, I used to work with her.
Yeah,
and I was like, oh, right, she worked at Procore. Yeah. So this seems to be organizationally something you guys, your organization thinks a lot of. So for our listeners, that was episode 87, I believe, if I did my quick research in the background there. But I remember, I remember really appreciating that book when I had a chance to wrap my head around it.
Yeah, so I had a relatively short second career as an Agile consultant, which is why I can talk about this and not sound like a dumbass. I care a lot about team health and well-being, about the team's capacity for execution. Can they solve difficult problems? Can they do that in a way that delivers software that is good enough for the customer? And so because I care a lot about this, in whatever organization I'm in, I seek out people who also care about this. And I found that in Heidi. And Heidi was exceptional at operationalizing the things we're talking about. And I don't have the same skill set she does. And so the thing that I would honestly recommend to our listeners, if you are struggling with this problem, is find yourself a Heidi. Find someone who has proven track record of operationalizing the solutions to these problems, and then give them a wide remit to go solve this problem.
Do you think this is something that is more appropriate for anyone listening, like if like the sense of scale, like do you think this is what someone like a Heidi would be helpful with a team of like 10 engineers, or is this like more for like teams of like 100 plus 500 to
Yeah. One of the interesting things about organizations is that they are recursive in the sense that we keep solving the same problems at different scales. So the problems that the people on a team experience working together are very similar to the problems that multiple teams experience working together. And so large organizations just recapitulate the problems of small organizations at a different scale, right? And so what really matters then is, first of all, if you're a large organization, then to some extent you've solved the smaller problem because you had to get to the state you're in today, right? And so what's important is, first of all, what is the level at which you need to solve this problem first? And then can you afford a Heidi to solve it at that level, right? If you're a startup that has a 10-person team, do you need a Heidi? Maybe you need like a Heidi Junior. Maybe there's, someone with 5 years of experience in this space that could be effective. But if you're an organization with 50 teams, you probably need someone with a much more developed skill set, right? And you're going to pay for that.
This might be a slightly odd place to go, but I think the last time you and I crossed paths in person, because we both live in Portland, Oregon area, was many years ago. And I believe the technical section of a Pal's bookstore here in Portland. And both of us were standing around, I think, looking at software books. And you recommended to me, or I don't know if you were picking up a copy of a Weinberg book or something. And you're like, you should check this out. And I got one of those books. And I think I got a couple more of his books since then. And so I just want to say thank you for that. Do you recall how you came across his work by chance?
I recall exactly how I came across it. Back in the mid-2000s, I was a fresh-faced software engineer, junior software engineer, working on my first real software engineering job at a consultancy called HashRocket in Jacksonville, Florida. They did rail consultancy. For a while there, they were one of the premier sort of boutique rail shops. And the CEO of the company, Obi Fernandez, who went on to be the managing editor of a series at Addison Wesley, he gave me Secrets of Consulting. And he said, if you want to read one book to become a better consultant, read this book.
Published in 1985, folks. I'll definitely include a link to that in the show notes for everybody as well. And that was the first book that I picked up by him as well. And I think Obi was also one of our prior guests, so I'll also include links to that in the show notes for folks.
And so Jerry likes to write books in a way that are easy to remember. So he tells a lot of stories and he provides a lot of mnemonic devices. And one of the Secrets of Consulting book is framed around a collection of consulting rules of consulting. And the first two of those rules have stuck with me for the past 20 years. And they are: 1, no matter what the client tells you, there is always a problem. 2, no matter what the problem looks like, it is always a people problem. So in the context of software maintenance, what that means is that if we want to get better at maintaining software, we need to work in the space of people and not in the space of code, actually. We actually need to spend more time, I believe, working on maintaining our understanding of software. Because our understanding of software is prior to everything we do to maintain software. Everything we do to maintain software depends on how well we understand the software we're maintaining.
That makes sense. Can you give me an example? Like when you talk about software with your team, are you talking about iterating on your best practices, reinforcing those things? Or are you more specifically talking about like, let's talk more about our code base and just keep talking about it as people? And maybe elaborate on that a little bit. I'm trying to think of some tangible examples for our audience here.
So there is a theory of skill development of expertise that says that when people have low expertise, they tend to focus on the external or superficial aspects of the task. And so in software, that means bike shedding. And so bike shedding is an indicator of low skill. And I don't say that to put people down. I say this is diagnostic. And so the indicator, the marker of high expertise is that you spend time talking more about purpose and these sort of deeper qualities of software. And so you aren't saying, are we following the style guide in your code review? You're saying, does this software do what it's supposed to do, right? Does it have a good design? Is the algorithm that we've chosen appropriate? Is the organization of the components and the way they interact effective, right? So as a principal engineer, it isn't just my job to review code, it's also to review code reviews. And so what I try to do is develop on my teams a way of thinking about software where we're asking these questions. And what's actually been interesting about the use of LLMs in software development is that they've effectively solved the style problems. In Rust, you just have a format to format your code for you. LLMs have solved this. So a lot of these markers of low expertise have now been hidden. Because even a junior engineer, even a really junior engineer, can produce code that looks superficially highly competent. And so it's become even more important today to care about these markers of high expertise, because actually these are now more surfaced, more available to us. So it's much easier now, and this is a value, this is a good that has come out of this. It is much easier now in a code review to spend your time talking about things that actually matter.
Do you think there's a a bridge for people that are earlier on in their career? How do you build up that confidence to have conversations about those things when, I mean, historically learning how to code, it's been so much more at like the syntax level. Like, is this work or not? Does the test pass? Is the linting passing? All those little checkpoints. And we can have those, we try to automate that stuff in our code reviews. So we're not spending time being like, hey, this doesn't match our style guide, or all those conversations that have added conflict and weird little conversations. We've done a lot, I think, in the industry to try to take humans out of some of those non-subjective parts, I suppose. But how do you get people into that space of being like, let's talk about this at a higher level?
Yeah. So the thing that we have to engineer now is sense making, is our ability to make sense of our environments. And so junior engineers used to spend a lot of time learning the syntax of the programming language they were using, learning how to use their tools effectively. And to some extent, that burden has been significantly lessened. This is an opportunity now to spend time, and a lot of this is mentoring and coaching, in my mind. So if you have technical leadership on the team who is able to, has the skill set around developing these skills and the engineers on the team, this is very helpful. But if you're a junior engineer who isn't getting this sort of coaching, then what I would say is, first of all, when you're using AI, it's not going to give you the signals you need to understand that it's wrong. It will very confidently be wrong. And it will do that despite any attempt you make to tell it that it's wrong. And you actually need to be able to know when the code you wrote is not the right code to do the thing you're trying to do. You always needed to know that. It's just much more important today.
That feels like such a big, I mean, I feel like that is an interesting thing to, like, we're all going to have to, like, be a part of figuring out how to help people get to that point. Because I do think it's like one thing to be earlier in your career and be like, well, the AI tools, your LLMs are generating quite a bit of code to help work on a Jira ticket, whatever. And you're reviewing this, you're like, well, it seems to be passing the test. What are the things I need to be, you don't have that historical context. Be like, well, maybe this smells off. Like, oh, it's not, like it's working, right? Or it seems to suggest it's working. And like, I don't know how to help people be like, I don't know. It's hard to transplant that knowledge without having to live with the consequences of the code that you've written or your teammates have written, and you needed to help improve those things. And so the pattern recognition is not necessarily easy to share.
Yeah, you have to develop this, and it's developed in part through this attentiveness to weak signals. And so sense making involves our ability to interpret the signals provided by our representations, to go back to line of representation, and then to build and construct and maintain accurate mental models of the things that we're interacting with, and then to decide on and coordinate effective action. And so you understand a system to the extent that you can act on it to achieve your goals. And so to develop this, it's important to understand that the line of representation is malleable. You can engineer it. And so when we talk about, for example, the importance of observability, what we're talking about fundamentally is engineering the line of representation to create better signals, right? So if you're having trouble interpreting the signals you're getting, the next step is to ask, how can I get better signals?
Can you think of some more tangible examples of like something where you might have had a weak signal and like, okay, we can improve our instrumentation or observability to have better data, better information for ourselves?
Yeah. So every incident contains a collection of weak signals that, had you been able to understand them at the time, would have contributed to the effective response of the incident. And often in hindsight, you can look back and say, oh, now I understand what that signal meant. But there is then a risk that what you do is you keep chasing the previous incident. And so what dashboards typically fill up with is the things that would have helped you a week ago. And to the extent that incidents are novel, and they often are in complex systems, that they involve some element of surprise. The thing that helped you last week is not likely to help you next week. And so this is why, for example, Charity Majors has shifted the focus of observability from this older definition, which comes from control theory, which says observability is a property of being able to interpret the internal state of system by observing its external signals. So it's a sort of black box theory of the system. what she has shifted to is an understanding of observability in terms of its contribution to sense making by saying a system is observable to the extent that we can ask it questions we've never thought of before and get an answer. And so that is what you need to respond to incidents and to maintain software, because the competitive environment, the environment that companies and teams are operating in, they require us to deliver novelty. They require us to, every new feature, right, is an opportunity for the system to fail in a way it's never failed before. And so we will continuously experience surprise. And it's actually our ability to respond to that surprise, which is called adaptive capacity, which is central to this concept of resilience engineering. And so resilience engineering is, in fact, an attempt to answer this question, which is, how can you engineer the capacity to respond to surprise?
And that can show up not just in terms of having metrics or data available that you can look up for those questions you don't know that you need to ask, but from what I understand about, is this different than, where's the distinction between like resilience engineering and, let's say, using something like, chaos engineering? Or
chaos engineering is a methodology to introduce surprise into a system on purpose. So it is a way to develop these insights and develop these practices. I find that a lot of systems have plenty of homegrown surprise. And so when you're looking at chaos engineering, the question you should ask yourself is, do we get enough training on responding to surprise with the system's ability to generate its own surprise? And so for a lot of teams, I hate the concept of a maturity model, but for a lot of teams, they get enough surprise to train on already.
That's true. What do you think, though? I'm not like necessarily a proponent for or against chaos engineering, but do you think that the stakes are a little higher when you're dealing with the surprises that you're just naturally dealing with versus like, we're going to have some specific dedicated time to work through slightly hypothetical,
Yeah. When you're doing chaos engineering, you are bounding it in time and in scope. At least you try to bound it in scope. You have some idea not of what is going to happen, but at least where it's going to happen, right? I'm chaos engineering this system. I am not chaos engineering this system, right? And so all of that, what it does is one of the other advantages of chaos. So I am pro chaos engineering, but I think it's contextual. I think that another advantage of chaos engineering is it gives you opportunity to narrow your scope of interest and focus on the surprises generated by this system. And if you do chaos engineering well, you can bound that however is most useful to you. Whereas when the system produces its own novelty, you don't get to decide when or where that happens.
When you think about dealing with these incidents and you're thinking about how you, air quoting, make sure this never happens again, type of thing, which invariably it probably will happen to some degree. But where do you decide, or how do you think about like how much you're going to solve this problem indefinitely versus like good enough to get through the day for now, and then we'll come back to this at some point? Like,
So first of all, this idea that incident response, the aftermath of an incident is about preventing reoccurrence. Making that incident never happen again is misguided in the sense that most incidents don't repeat. They rhyme. Elements of that incident will be present in the next incident, but it will not happen the same way it did before. And so to the extent that the next incident contains some surprise, that's not good enough. And so what you find with organizations that really over-index on preventing reoccurrence is that they become less capable of responding to surprise because the things that you do to prevent reoccurrence by quote-unquote hardening the system also make the system more brittle.
How do you think about how much you're going to prioritize? Like, let's just resolve the issue for now. We're going to plug the hole in the system versus like, we're going to need to completely rehaul this situation.
Yeah, so this plugging the whole thing is called disturbance management. And this comes from healthcare. And for example, CPR is disturbance management. CPR doesn't heal anyone. It keeps them alive until they get to the hospital, right? And so what really good incident responders do well is they transition between the investigation phase, where they're trying to make sense of what's happening. They're engaging in sense making. Sense making is the priority in this phase. To the disturbance management phase, where they say, we know enough now to take an action. And our action is an attempt to restore or maintain the quality of service, right? So the first priority in this isn't to implement the long-term fix. It's restoration. of service. And so this activity is called disturbance management. And really good incident responders both know when to switch and know how to switch, and also are able to go back and forth as the situation evolves.
Hey folks, it's Robby here. I want to take a quick second to talk about something we've been doing for a long time at Planet Argon: fractional development and team augmentation. When a team's juggling product work, tech debt, and upgrades, it helps to have experienced engineers who can drop in, get up to speed fast, and keep things moving. Yes, LLMs and AI's tools are useful. We use them too, but experience still matters, especially with older apps. Most of the time, the hard part isn't writing the code. It's knowing where it fits, what it might break, and how to move forward without slowing everything else down. That's what we help with. We work with teams using Rails, Laravel, Vue, Next.js, React, just to name a few. If your team could use a few extra hands, maybe for a short, limited time, we'd love to help, because good software deserves a second act. Visit planetargon.com. That's planetargon.com. All right, let's get back to the show. You know, it's interesting. I like that example of comparing it to okay, someone, having to go through CPR and they're in the ambulance but they get passed off to another team once they get to the hospital. And I guess you can kind of think about that in terms of software. There's an incident, you plug the hole, you disturbance management, bring it in, and then you're going to decide, okay, you don't maybe necessarily have the people that are handling the incident to be necessarily the ones that are thinking about the long-term solutions to it. Maybe in software we do that and you want to spend time doing that, but sometimes that could be intentionally separate teams, okay, well, things are back up and running. We're going to pass over all the information over to the next team. We'll pick this up next week. That team can pick it up, or however your organization organizes that type of work in there. So I think that's an interesting way to kind of frame that.
Yeah, and I think I would call back to Kent Beck's episode where he talked about optionality. And I think that what he is calling optionality has a better name. And so typically, this idea of optionality comes from economics. And the textbook definition of optionality is about the ability to choose among a set of known actions in the future. And so optionality under this definition involves maintaining that set of options, both by generating them and also by not foreclosing on them by taking other options. And so this form of optionality has a cost. And in fact, it's the cost of foresight. Foresight is expensive. But what Kent Beck was talking about was the ability to preserving the ability to make good changes later, even if you haven't already thought of them. And so for him, this was about judgment, timing, legibility, reversibility, right? And it's created through practices like tidying, refactoring, these small, structural improvements that make a system more malleable. But so optionality is not a good fit for the concept that he is indexing with it. The better fit is adaptive capacity. Adaptive capacity refers to our ability to respond to unexpected surprises. And it refers to the capacity we have as humans. Humans are the unit of adaptive capacity to change the system in ways that maybe we haven't thought of yet. And almost every incident involves that. In almost every incident, someone had to come up with a creative problem-solving solution.
And in that situation, keeping that in mind about, I think you're saying adaptive capacity, for our listeners, how would you, if they're let's say that they're dealing with some maintenance work right now and they're trying to think about well, do we go through the process of refactoring this big piece of code right now or maybe rewriting it? What sort of advice would you have for them on how to kind of incorporate that and making sure that they have that capacity in the future to not be stuck with all the decisions from today?
So we're getting to the end of the hour, so maybe this is a good way to put a little bow on the episode. What I would say is that adaptive capacity comes from our ability to understand the system and to develop options in real time for how to intervene in the system. And so that comes from being attentive to weak signals that we don't understand the system or that are shared. There's a gap in our shared understanding of the system. So when someone says, wait, is that how it works? That's something you want to dig into. Because if that person is trying to act under uncertainty in the middle of an incident based on that misunderstanding, they might do the wrong thing. Or also, alternatively, I could be wrong. They could be right, I could be wrong. But there is a gap, and someone might be wrong. Or actually, no one might be wrong. You might just understand two different parts of the system. But those gaps are what are going to prevent us from working together. And the clarity and fidelity of my mental model of the system is what enables me to take action in the future.
Using that particular example of where someone asks that kind of question is that how it works? And you're like, in that scenario, how do you verify that you actually do, your recollection is accurate? Because you just said might be the scenario, like I might actually be a little off, but do you kind of advocate for stepping through and verifying that that's the way it works to show?
It depends a lot on how much time you have. So when experts operate in highly pressurized situations, this is Gary Klein's decision-making research. What they don't do is spend a lot of time deeply analyzing the problem, developing different options, choosing among those options. Something based on their experience and understanding and recollection of the system is going to present itself to them as an action that's worth pursuing. And then they're going to do what's called mental simulation. They're going to say, if I took this action and I imagine what the consequences would be, am I satisfied with those consequences? And if they are, they're just going to do it. And so and if they're not, they're just going to come up with another one and do that process again until they find one that they're satisfied with. And during an incident, we typically don't have enough time to fully unpack our models and get to this level of deep shared understanding that's required. And so this is where it's important to do what's called epistemic delegation. Epistemic delegation says that, for example, I'm an incident commander. It's ultimately my responsibility to know what's happening, to tell people, to make sure that the right actions are taken, and so on. In a large incident, or even in just a small but fastly progressing incident, I don't have the time to understand everything. And so I have to do what's called epistemic delegation, which means that I delegate to you the responsibility to understand this system, to decide on a course of action, and I have to trust you. And so developing that trust through shared experience, which honestly can just often come from responding to incidents together. But if incidents are a microcosm of maintenance, then maintenance is a macrocosm of incidents. So in other words, the work that we do together to maintain our systems is preparing us to respond to the incidents.
I think that is helpful. I think that's a useful example as well. And I'm gonna definitely include a bunch of links to a lot of these things. You said it was episodic delegation.
Epistemic, in other words, having to do with
epistemic.
knowledge. Epistemic delegation.
You know, well, these fancy words, because you're so much smarter than me, Rein.
No, I just read a lot.
You read a lot, and I appreciate that.
Nerd. Anyone can understand this stuff. It's just whether they choose to spend their time on it.
Understood. Well, I've definitely kept you long enough on this, Rein. I have a couple of quick last questions for you. First of all, is there a non-software, non-technical book that you find yourself recommending to peers?
You said non-software, and then you said non-technical, as if those mean the same thing. I just want to call out that they don't. There are many highly technical non-software books, right?
Fair enough. Fair.
And I point this out because it becomes a problem. Not between you and me, but it becomes a problem when, for example, the engineers on the team disrespect the skill set of the product manager because the product manager isn't quote unquote technical.
I completely agree with that. So I think about it more of, I think maybe a better way to phrase my question is like, is there a book that you don't think your peers would normally be gravitating to that you would? Yeah.
Absolutely. And I don't mean to call you out here. I'm not trying to call you out.
Yeah. No, I appreciate that. Yeah, I get that.
There's a book called The Field Guide to Understanding Human Error by Sidney Dekker, and it is foundational in what has become known as the new view of safety. And so the old view of safety, which has come to be called Safety One, is that the thing you do to make something safe, a system, a hospital, a factory, and in our case, that means to have fewer incidents. The thing that you do to make systems safe is you find the mistakes that people are making and you stop them from making those mistakes. The new view of safety is, in fact, everything that people do that quote unquote causes an incident is the same stuff they're doing every other time when there isn't an incident. And what they're doing is they're adding value to the system.
What was the name of the author for that again? Was it Dekker?
Sidney Dekker.
Sidney Dekker.
And so the idea of the new view is that incidents or accidents are the result of the variability of normal work. And we can try to control that variability, but it's a category error to say, oh, incidents happen because of human error.
What causes incidents if it's not human error?
It's the variability of normal work. It's the fact that we can't have sufficient foresight to fully understand the outcomes of our actions. It's that our actions can have a range of outcomes, and we can't fully understand that range or the likelihood of different outcomes. It's that when I write code, there are a million different ways that code could cause an incident, but there are also even more ways that it could be successful.
I like that. We'll definitely include links to that for our listeners in the show notes. And with that, Rein, it's been such a pleasure. Thank you so much for stopping by to talk shop with us on Maintainable.
Thank you for having me, Robby.
You've been listening to Maintainable, a Planet Argonne production. Editing by Claudia Armbruster. Post-production by Autumn Morgan and Ellis Svensson. Emotional support from the letter M. For Maintainable, for momentum, for making things better. If this episode resonated with you, share it with someone who needs to hear it. Keep showing up. See you next time. Maintainable.